Today we are going to discuss about the subqueries in SQL Server. So what is a subquery? What is a query? So the query is nothing but a question we are going to ask the SQL Server database engine. So we have the database engine, and this database engine can understand the SQL language, right? So whenever you want to talk with the SQL Server database engine, you have to speak with the language SQL language. Okay, for example, so I want a information from the SQL Server database engine. So what information? So I have some data in a table under this particular database MSBI. Okay, so under this MSBI, so there is one table, that is EMP table. So inside this EMP table I have some information. I want to ask that information. Select all the list of the columns. Try to write down everywhere in caps letter. Select star from EMP table. Okay, so in this EMP table I want only the information belongs to the department number 20. Okay, so you have to select the proper database. So instead of selecting here, you can write down like this way: use MSBI database. Okay, so whenever you are going to execute this one, it will use the MSBI database, right? So this information is coming for only the department number 20. So this is a query. This is a SQL query. You are asking the database engine, and now what I am expecting, what is this department number 20? How you know? So the department number 20 means select star from department. So in the department table you can see the what is the department name of the department number 20 means research department. So what exactly I am expecting, whoever the employees belongs to the department research. I want to see the people who are belongs to the department name research. Okay, so right now the department number of the department number 20 is for the research. So if you are writing these queries, select star from EMP where department number equal to 20, yes, definitely it will get the departmental information about the research. Later someone is coming and updating the value for the research equal to 50. Then what will happen this one? It don't give any result. Okay, the department name don't change if they are changing the department number. So in that situation we may face the issue. So that is the reason what I am going to do here. Whatever the updated department number for the department name research, how will you get? You can get like this way: select department number from department where department name equal to research. If you are executing this one, it will give the whatever the current department number for the department name research. So every time whenever you are executing this one, it will get updated department number from the department research. Whatever the department number is there for the department name research, it will get updated one. So instead of putting static value over here, what I want to do, I want to put this query over here. Okay, instead of giving the department number 20, I'm going to put this query. So this query will give, first it will execute this query and this will get the result. Currently it is 20. The department number for the department name research is 20. Okay, and after it is executing, whatever the result is coming, based on this result the outer query will execute. So we are calling this is a main query, or outer query. So we are calling this is a sub query or inner query. Okay, this is main query or outer query. This one is sub query or inner query. So when you are executing this whole statement, what is happening? I am going to execute this whole statement. Execute it. See, the department number 20th information is coming. First it is executing the sub query or inner query, and whatever the result is coming, so what result it is giving? So it is giving the result is 20. Okay, and based on this 20, this outer query will execute. This is the statement will come. So this is the result is coming. Okay, so in this way you can write down the multiple subqueries. Up to 32 levels you can write down the subqueries. So where you can write down the subquery? So we can write down a subquery in the where clause. Okay, we can write down a subquery in the where clause. How many kinds of subqueries we have? There are two kinds of subqueries we have. This is very important interview question. Non-correlated okay, the second one is correlated subquery. So whatever we have discussed now, right? So this is non-correlated subquery. In non-correlated subquery, the inner query will execute first and it will return a result to outer query. Okay, the inner query will execute first and it will return a result to outer query, and based on that result the outer query will give the result. That is non-correlated. So always this non-correlated query is in one direction. The direction is in this way, from inner to outer. So what about this correlated subquery? Right, for example, I have a data like this, select star from EMP. Simply I am going to create a simple table. In another database I am going to choose create table. If there is already table, I want to drop the table. Drop table EMP. Okay, right. Create table EMP, employee number integer, employee name varchar, comma, salary integer. Done. Okay, so this is the table I have created. Select star from EMP. I don't have any data. I want to insert a data. Insert into EMP values 100 comma RAM comma 1000, okay, comma 200 comma Deepthi comma 2000 comma 300 comma Himaja comma 3000. So in this way also you can write down the insert statement. Okay, at a time it will insert 3 rows. Right, normally how we are writing, every time we are writing insert into EMP table, and what are the list of the columns. If you are going to insert all the values into all the list of the columns, then you no need to specify the list of the columns. If you are going to insert only for a specific columns, you have to specify the columns. So it will insert this row and the second row and third row. Okay, so if you want guys, I will insert one more row also. Okay, 400 Swaran comma 4000. Okay, right, 4 rows affected. See, these are the 4 rows inserted. Okay, right. So now I'm going to write down a correlated subquery. Right, so in this correlated subquery, by using this one, I want to find out the what is the second highest salary in this employee table. So what is the second highest salary? This one. So if you want to find out the second highest salary, other than using this correlated subquery, we have one option by using one of the keyword. So what is that? Top keyword you can use like this way. Select top 2 star from EMP. So what it will give? This is giving top 2 records. Okay. So what you want? I want only the second record. This one 200 DP 2000. That means you have to eliminate the first record. How will you get the first record? Select top 1 star from EMP. If you are executing both, what is happening? This is giving, the second query is giving only one record. The first query is giving 2 records. So what I want to do, from this first query, I want to eliminate the whatever the result is coming from the second query. How? I want to select only the select top 1 employee number. Okay, so whoever the top 1 employee, so that employee information I am going to eliminate by writing a non-correlated subquery where employee number not in. Sorry, now we can write down the top one. See, this will come. Okay, so normally first what result it will get? It is excluding 100 employee information. Select star from EMP. Okay, so what I want to do, out of this result, whatever the top 1 employee, 100 RAM 1000, so I'm going to eliminate this one. The remaining are 200, 300, 400. So out of these 3, what is the first one, top one? 200. Okay, this is this query will get this result. So here you are getting only top 1 or top 2, top 3, top 4, top 5. So in this way, if you want to find out a top 100, so you have to write down that many number of subqueries. It is difficult. So that is the reason what we are going to do here. We have a correlated subquery. So that correlated subquery, whatever the highest employee salary information you want to find out, simply you can specify that number. Okay. Right. So this is the way you have to write down the subquery. Select star from, star means all the information from the EMP table. So alias name I am going to give this is E. Select star from EMP as E. Okay. Where, so what is the number, which highest salary you want to find out? I want to find out the third highest salary. If you want to find out the second highest salary, give second. If you want to find out the 100th highest salary, you can give. So whatever the number you want to get, so you just specify that number. Okay. I want to find out the third highest salary. Select star from EMP as E, where third highest salary equal to, okay, bracket open, select count salary from EMP. Give alias name as E1, where E1 dot salary less than E dot salary. E means outer table. I will explain it clearly. So select star from EMP. This is the outer query and this is the inner query. So this inner query and outer query are going to start the comparison over here. E1 dot salary means inner tables salary and E dot salary means outer query salary. Okay. So how it is going to perform the execution? Okay. Right. So this is the result we have in this table. This correlated subquery first will execute outside query. But in our non-correlated subquery, the inside query will execute first. This part will execute first in non-correlated. And whatever the result is coming, it will give, and comparing in the where condition based on the condition satisfaction, the outer query will give the result. But in correlated subquery, it is reverse. First, the outer query will execute. Okay. So first the outer query will execute. So what result is coming here? This is the result is coming, the entire table result. Okay, right. So first it will send a single salary value to over here. Okay, right. Control C. You have to put less than or equal. Okay, right. I will explain you how the execution will happen. So when this is executing the first select star from EMP, this is the result is coming. So now what it will do? It will send one value to inside query. What value it will send? See here, E dot salary. E means this is the table. This is the result of the E table. And whatever the result is there, 1000. It will send the value 1000 over here. Okay, right. So here it will come 1000. So this inside query is going to execute and it will find out the number of salaries based on the condition is satisfying. What condition? The E1 dot salary less than or equal to 1000. So the E1 table is also same the EMP table. So what are the salaries we have in the E1 table? 1000, 2000, 3000 and 4000. How many salaries are less than or equal to 1000? How many salaries are less than or equal to 1000? Only one salary. Am I right? Only one salary is less than or equal to 1000. Then that is the count will come 1 or 2. How much will come? Sorry. How many salaries this 1000 is less than or equal to how many salaries? 1 only. Okay, right. So whatever the condition is coming here, the value, it is not satisfying. The count will give 1. The next it will send the 2000 over here. So how many salaries are less than or equal to 2000? The count is 2 because 1000 is less than 2000 and 2000 is equal to 2000. Okay. So how many salaries are less than or equal to 3000? The count will come 3. So what we are expecting? The third highest salary 3000. So the count of salaries are how much is coming by satisfying this value? So that is count will come 3. So 3 equal to 3 for which record? For Emaja. Okay, sorry guys. So we are expecting the third highest salary, right? What is the third highest salary? This 2000. The result what we are expecting? This is second highest salary. E1 dot salary greater than or equal to. Right. So you have to put instead of less than, greater than or equal to. Oh, great. I have this result. We are going to pass first 1000 value over here. Okay. So in this EMP table that alias name is E1, total how many salaries are? 4 salaries are there. How many salaries out of these 4 are greater than or equal to 1000? 1000 is not greater than but equal. Yes, condition satisfied. One value is coming. Then immediately it will check for the second value. 2000. Yes, 2000 is greater than 1000. So plus one more value. And 3000 is greater than 1000. Yes, plus one more value. And 4000 also is greater than 1000. Yes, one more value. The total count how much is coming? 4. So the count of salaries is 4. Is 3 equal to 4? No. So then whatever the value you are sending 1000 for this condition, it is not satisfying. So this is not the third highest salary. Okay, right. Now instead of 1000, the second value we are going to pass, that is 2000. So now what will happen? How many salaries are greater than or equal to 1000 out of these salaries? Is 1000 greater than or equal to 2000? No. It is not giving the count. It is not counting the value. So these 2000 is greater than or equal to 2000? Not greater than but equal. Yes, condition satisfied. So the count 1 will come. Then this 3000 is greater than or equal to 2000? Yes. Then this 4000 is greater than or equal to 2000? Yes. So the total count is coming 3. So the count of salaries are 3. So is 3 equal to 3? Yes. So for which record it is satisfying the condition? That is 2000. So this is the third highest salary. So what will happen? First this outer query is executing and it is giving a record to the inside query, and whatever the record is coming here from the outer query, the inside query will count the number of salaries based on this condition. Okay, then it will get some value and that value it is giving to outer query. So it will check the condition whether it is satisfying or not, then the outer query will give result. So this is a two-directional query. Outer query will give result to inside query, then inside query will give result again to the outer query. Finally, the outer query will give the result. It's a two-directional subquery, correlated subquery. If you are putting here 2, the second highest salary is 3000. It will give 3000. Sorry, you have to put this value, E dot salary. See how this result is coming. The second highest salary, how we are getting? First this query is executing. This is the result is coming. So this 1000 value we are going to pass over here because E dot salary. E means the outer query table. So here the 1000 will come. How many values in your inside table? This is your table. So in this table also same like a EMP table only. So this table also having 4 values. How many salaries are greater than or equal to 1000? 4. 1000 equal to 1000, 2000 greater than 1000, 3000 greater than 1000, 4000 greater than 1000. So total count will come 4. Is 4 equal to 2? The count will come here 4. Is 2 equal to 4? No. Then the condition is not satisfying. Then it will come to the second record. Again it will send the 2000. So how many records in your inside table, EMP table, that is E1 table, are greater than or equal to 2000? So the 1000 is not greater than or equal to 1000. So it don't take the count. So 2000 is equal to 2000. The count will come 1. Then 3000 is equal to, not equal, greater than 2000. Condition satisfying, whatever the condition here. So count will come 1 more. And then 4000 is greater than or equal to 2000. 1 more is there. So count will come 3. So is 3 equal to 2? No. So it don't take the second record also. Now come to the third record. So instead of 2000 it will take 3000. How many salaries here are greater than or equal to 3000? Only 2 salaries, 3000 and 4000. Because 1000 and 2000 are less than or equal to 3000. So the count will come 2. So is 2 equal to 2? Yes, 2 equal to 2. So for which record it is satisfying? That is 300 image 3000. So the second highest salary will come over here. Okay. So this is the way you can find out the second or third highest salary. But in the performance point of view, this query is taking too much time because it has to compare each and every value. Right, for example, if two persons having the same salary, So I'm going to insert one more record. Insert into EMP values 500 Varun. This person also having 3000 salary. So that means there are two persons having the same salary. This person and this person. These two people are the second highest salary. Okay, right. So if you are executing this query, what it will give? Okay, so the third highest salary is 3000. Two people are coming. Okay, right. So if you are putting here distinct keyword, what will happen? Right? Did you observe the when you are putting I want to get the second highest salary. So as per our old logic, it will get no, it is not giving anything. So what is the second highest salary? So there are two people for the second highest salary, 500 and 300. These two people are second highest salary. But why it is not giving the second highest result? Because so what will happen when if we have more than one person for the same salary, so in that situation you have to put the distinct. Okay, so even though if there is no person having the same salary, okay, you can put distinct, it will work. Okay, so don't forget to put distinct keyword. So if you are putting distinct keyword, if there is more than single value having the same salary, it will give the proper result. Okay, in interviews they will ask you to explain how it is going to compare. So you have to tell them, so 1000 will come, it is going to compare how many salaries are there, so whether that salaries are greater than or equal to or not. Okay, so what is the count will come, so whether that count is equal to these two or not. So you have to explain it this way. They will give simple four values like this way. Okay, and they will ask you, you can buy hard this one but no use. So try to understand how this query is executing, how this is sending the value inside, and how it is going to compare the values, and what is the count will come, whether that count is equal to the this count or not. Okay, so where we are writing the subquery, the place where we are going to write down a where condition, so we are specifying that is a subquery. Okay, right. So the next thing is, I have a table, that is EMP table, and I have another table, department table. Okay, so I want sum of the columns from the both tables. Okay, because whatever the columns I have in this table EMP, what are the columns I have? EMP table, and the next one is select star from department table. We'll go to this database. Okay, so these are the list of columns from the both tables. So for a particular users, I want to give only to access the columns employee number, employee name, and his job, okay, and his salary. I don't want to give any permission on the commission column. How can we do? We can't do, right? Because we can restrict a person on a table level, not on the column level. We can give a permissions to a person on a table level. For example, I can give permissions to the EMP table. I can give permissions to the EMP1 table. I can't give permissions on the column level. Because for example, sometimes if you want to give access only for employee number, employee name, job and salary. I don't want to show this what is the commission for each employee. Okay, and also I want to give only the department name. I don't want to give permission on the location, which employee belongs to from which location. I don't want to disclose this information to the users. So how can we do? Because we don't have this kind of feature in the SQL Server to give the column level restriction. Either you can give the entire table level or you can restrict the entire table level. So what is the solution? So the best solution is views. In a real-time scenarios also, mostly the client will give permission on only the views. They don't give a direct permission on the tables. So what is a view? A view is a virtual table. We are going to create a view by using different tables, and whatever the columns you are required, you are expecting. So we are including that columns inside the view, and instead of using those tables, you can use this view as a table. Okay, right. So for example, what are the columns you are expecting? I want only employee number, employee name, salary, job, comma, department name from both tables, from EMP as E, okay, inner join department table as D, on E dot department number equal to D dot department number. The relation between these two tables is this one. See, you are getting the department employee number, employee name, salary, job, department. So how to create a view? Create view. What is the view name? The view name I am going to give E underscore V underscore EMPD as. So you have to give the syntax like this way. Create view name as select what are the list of the columns. So this query. So if you are executing this command completed successfully, a view is created. So where you can see the view under this database, under the views you can see over it. The view name is v.empdept, v underscore empdept. Okay, so this view is just storing the query, whatever the query you are writing here, and this is storing the query. It is not storing any database. It is just occupying the storage only for this query. It is not storing this result. So whenever you are going to call this view, okay, whenever you are going to call this view, what it will do? It will try to execute this query and try to get the result from these two tables. Okay, so how to call this view? Simple. How you are treating your normal tables, you can treat this view also. Like right, select star from, what is the view name? This is the view name. See, the same result is coming. Whatever this query is giving the result, the same result we are getting from this. Okay, so now what you can do, you can give a permission to that persons, that users only on this view. If you are giving access on this view, they will get, or they will access only employee number, employee name, salary, job, department name. They can't see the commission, they can't see anything other than this. Instead of giving access on the EMP table, instead of giving the access on the department table, if you are giving access on the EMP table, they will see all the information in the EMP table, because some information is confidential. So in that situation, you can create a view with some of the columns from multiple tables, and you can give access to the users on this view. Okay, right. For example, so this is the view. How will you get whatever the code, whatever the select statement you have written for this view? The create script for this view. Either you can get like this way. Right click, select view, create new query window. So this is the create script for your view. Other than using this graphical user interface, so by writing a simple command, sp underscore help text, what is the view name? This is the view name. So if you are executing this command, it will give the create script. This is the create script we are using for creating a view, right? Create view, this is the view name as, right? Later if you want to add one more column, or if you want to remove one of the column from this view, I don't want this salary column, or I don't want this job column. So what you have to do, you have to alter this view, you have to modify this view. So instead of create, alter view, what is the view name, and I have removed one column. Command completed successfully. We'll check whether it is altered or not. Right? So from this, the job column is missing. Only employee number, employee name, salary, department name is coming. So you can execute this one. Job column is missing now, because we have removed the column from here. Okay? So this way you can alter your view also. So now what I want to do, we are selecting this view, select star from whatever the view. So it is acting like a table only, right? So what exactly the structure is there in your MSBI database? This is your MSBI database. You have EMP table and you have department table. This is EMP table and this is department table. So in high level, what we are doing, by using these two tables, we have designed a virtual table, that is view. So what this view is storing? This view is storing select some of the column names from EMP table, inner join, so department table. So whatever the query it is storing. So I am the user, I want to call select star from whatever the view name you have created. So whenever the user is writing this query, so it is going to contact this view. What this view will do, whatever the query inside this view, This will execute and get the data from the EMP table as well as department table. Then it will return result to the user. Okay, right. So if you are writing the select query, it will get the result. If I am writing a delete command on this view, or if I am writing a update command on this view, where it will change? Because the view is not storing any data, then where it is going to update that record? For example, if I am deleting a particular employee information, delete from the view name like this way. Delete from v underscore emp dept where employee number equal to 7521. So where it is going to delete this record? This view don't have any data. This is just storing the query. The data where it is located, where it is stored. The data is stored in the EMP table, the employee information. So it will delete that employee information in your EMP table. It will affect your base table. Yes, it will delete the record in the EMP table. Whenever you are writing a delete command or update command, okay, it will affect in your base tables also. There are specific conditions are there. For example, in your query, when you are writing this view, in your query, if you are using group by, top keywords, these kind of keywords if you are using, you can't delete, you can't update the records. So you have to write down only the simple queries without any restrictions. Okay, I want to use another database because I don't want to delete the record over there. So I want to create this view, create view, sorry, the department number, and this is also department number. Create the view, column E number. Okay, the EPT number. I think we don't have. Okay, right. Just come back to our MSBI only. Okay. So for example, I am going to create a view. Create a view v underscore emp dept. This is my view as select sum of salary, comma, and department number from EMP group by department number. Okay, so I'm going to create this one. Create a view or function field because of the no column was specified for the column 2. So whenever you are writing these aggregate functions, you have to specify the alias name. Okay, command completed successfully. Select star from, what is the view name? This is the view name. Sorry, this is the view name. If I am trying to delete a record, delete from this view, okay, where department number equal to 10, what will happen? See, it is throwing error. Cannot update the view. The view name is this one because it contains aggregate functions. Whenever you are using any aggregate functions in your view, you can't delete, you can't alter. Not only the aggregate function, if you are using distinct keyword like this way, for example, select distinct star, you can't delete this query also. Or if you are using any group by class, or if you are using pivot unpivot operators, so in that situations you can't update. So when you can update, other than these situations you can do. Okay, right. So every time whenever the user, someone is trying to see the code what I am using inside this query, I don't want to allow the people to see the create script of this view, sp underscore help text v underscore emp delete. So in that situation, whenever you are creating this view, you can encrypt the code. Encryption means we don't want to show the create script for any others. So simply you can add with encryption. With encryption. See, if you are executing this one, the text object v underscore emp department is encrypted. Okay, it don't show any data, the create script. Am I right? Right. So the next situation is whatever the tables you are using inside over here. So the next one is whatever the tables you are using inside this view, if someone is trying to drop this table, so what happened for this view? Because we are using EMP table, department table, and this is the view. This view is using EMP table and department table. Someone is dropping this department table or EMP table. So when you are calling this view, what will happen? The view is looking for the EMP table, but the table was dropped by someone. So these kind of problems will arise. So in that situation, what we are going to do here, if anyone is going to drop this table, first they have to drop this the view. Whatever the views are created on this table, they have to drop this table, then only they can drop this EMP table, otherwise they can't drop. So how can you do that one? So you have to apply the property with schema binding. If you are putting the with schema binding when you are creating the view, okay, so when you are creating this schema binding, you have to put the schema name in front of the tables. These tables belongs to which schema? DBO schema, right? See here under MSBA database, these are the tables, all belongs to DBO, 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 DBO. Execute this one. Command completed successfully. Now I want to drop table EMP. So you can't drop. You can't drop this EMP table because the view is depending on this. So first you have to drop these views, then only you can drop the tables. That is schema binding. Okay, right. So you have this EMP table and you have department table, and this is your view. So when the user is requesting for the view, then this will contact the tables. If you want to improve the performance of the view, or if you want to improve the performance of the tables, normally what we are doing, we are creating the indexes. how you are creating an index on the tables, the same way you can create the indexes on the view also. We'll discuss in later sessions how to create a indexes. If you are creating an indexes on this table, that is we are calling indexed views. In Oracle we are calling those are materialized views. Okay, I will show you in when we are discussing in the indexes, so how to create the indexes on the views also. Okay.